Hello and welcome to today's lesson on thermistors, LDRs and control circuits. So have a look at these pictures. What do they all do and how could they work? So obviously this is street lights, they turn on when it gets dark. These two are thermostats. This is a bit more intelligent, it controls air conditioning as well. And how do they work? Well, they generally turn on when it gets too cold or too hot. So we have a circuit that responds to light and circuits that respond to heat. And that's what we're going to look at in today's lesson. How do we design circuits that respond to heat or light? We're going to look at two new components that do this. So the first component that we're going to look at is a thermistor. So a thermistor has this really interesting property where its resistance decreases as temperature of it increases. So usually if we have a wire, if we have a bulb, as temperature increases, resistance increases. But thermistors are special and do the opposite. They're sometimes known as negative temperature coefficient components because of that, because the temperature increases, the resistance decreases, the opposite of normal resistors and bulbs. So what do they look like? They generally look like this. Sometimes they're bigger, sometimes they're smaller. Not particularly exciting to look at. This is the circuit symbol, a box with the wires coming out and this hockey stick through it. No idea why it's this symbol, but it's often known as the hockey stick symbol for a thermistor. And here is all the information I've just said summarized for you to take a note of. They might ask you for uses, so central heating, air conditioning, ovens use thermistors. Sometimes kettles do, but usually kettles actually use something different. They use a piece of metal that changes shape when it gets hot, but sometimes they might have thermistors in. Now, importantly, if the temperature is constant, they act as a normal resistor. So if the temperature is not changing, they act as a normal resistor, current voltage directly proportional, straight line through the origin, just like a normal resistor. It's only if the temperature is changing do they do something interesting. Our second component is called a light dependent resistor, or LDR for short. Usually you see them written as LDR. This is special because as the light intensity increases, so as the brightness of light increases, its resistance decreases, which means you have light sensing circuits. You can build things like street lights that turn on when it gets dark, or a security light that turns on when it gets dark. Or if you have a phone that changes its screen brightness when you go outside or inside, that probably has an LDR in. If you have an automatic flash on your camera that automatically goes on when it gets dark, it's because an LDR is sensing the light intensity, the brightness. So they tend to look like this. This is a cartoon, but fairly good image. This is the circuit symbol. It's a resistor with arrows going in, clues in the name really. It depends on light being shone on it, and it's a resistor, light dependent resistor. Here is all the information I've just said, summarized for you to make a note of. Then you can pause the video and answer the questions on LDRs and thermistors.